The morning of May 12, 1942, inside the vast shell of what would become the world's largest factory, a tool designer named Robert Clem stood before a problem that threatened to collapse America's entire war production effort. Before him lay the center wing section of a B-24 Liberator bomber, 55 feet of curved aluminum, honeycombed with fuel tanks and structural spars. Each one needed to be identical within tolerances of 2/10,000ths of an inch. Each one took Consolidated Aircraft's craftsmen in San Diego 250 man-hours to build, positioning every rivet hole by hand, checking measurements with plumb bobs and levels, adjusting, remeasuring, adjusting again. Ford's Willow Run plant was supposed to deliver one complete bomber every hour. The mathematics were brutal and simple. At 250 hours per wing section, producing enough wings for one aircraft per hour would require 250 simultaneous work crews. The plant didn't have room for them. America didn't have time to train them. And Charles Sorensen, Ford's production chief, had promised President Roosevelt something that now seemed impossible. One Liberator every 63 minutes, built not by master craftsmen, but by farmhands and housewives with 3 weeks of training. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Clem stared at that wing section and understood what few others had yet grasped. The war would not be won by better soldiers or braver pilots. It would be won or lost right here, in this cavernous building outside Ypsilanti, Michigan, by whoever could solve one question: how do you turn aircraft production from a craft into a science? The answer would come from a group of tool designers, machinists, and engineers who would do something unprecedented in aviation history. They would create fixtures, jigs, and tooling systems so precise that untrained workers could achieve what had previously required decades of experience. But in the spring of 1942, standing in that unfinished factory with skeptics calling it "Will it run?" and congressional investigators circling like vultures, that answer seemed very far away. This is the story of how American manufacturing evolved in a single desperate year, of how the forbidden became necessary, how the impossible became routine, and how a handful of innovations in a Michigan factory helped win the largest war in human history. On January 17, 1941, Charles Sorensen stepped off a train in San Diego carrying a single briefcase and a challenge that bordered on insult. Ford Motor Company had been asked by the government to produce wing sections for the B-24 Liberator, sub-assemblies, components. Someone else would put the pieces together into actual bombers. Sorensen was 60 years old, a Danish immigrant who had helped Henry Ford create the moving assembly line in 1913. He had supervised the construction of the River Rouge plant, where 100,000 workers could transform raw iron ore into finished automobiles. He was called Cast Iron Charlie by workers who admired his relentless efficiency and feared his volcanic temper in roughly equal measure. He toured Consolidated Aircraft's San Diego facility with Edsel Ford, Henry's son, and the company's president. What they saw appalled them both. The B-24 seconds weren't being built, they were being crafted. Each aircraft took shape outdoors, under the California sun, assembled on steel fixtures that expanded and contracted with the heat. Craftsmen positioned components using surveyors' transits mounted on truck beds. Engine installation required 4 hours per motor. Wing panels were custom-fitted to each individual airframe. When asked about blueprints, Consolidated engineers produced sketches and templates. The same part might be slightly different from one aircraft to the next. It worked because skilled mechanics could compensate. They could see where adjustments were needed and make them. Consolidated was producing one B-24 every 30 days. Maybe. Their goal was one per day, eventually. Perhaps. Martin Chapin, a Ford tool and die maker who accompanied Sorensen on that trip, later recalled the moment that defined everything that followed. The Consolidated engineers showed them a landing gear pivot assembly, 6 pieces of steel, 2 large tubes, flat plates, nearly 100 welds, each requiring X-ray inspection to verify quality. It took 3 shifts of skilled welders to complete one assembly. Sorensen asked how long it took to design. The consolidated engineer shrugged. They hadn't really designed it. They'd built one, tested it, modified it, built another. The process was iterative, organic. It worked. That night, Sorensen locked himself in his room at the Coronado Hotel. He worked through the night with nothing but hotel stationery, a pencil, and the architectural spaces he could hold in his mind after 40 years of manufacturing. By 4 a.m, he had sketched the outline of Willow Run, an L-shaped building over a mile long, parallel assembly lines with a 90-degree turn at the end. Capacity for 100,000 workers. Cost, $200 million, equivalent to nearly $4 billion today. The sketch was crude, almost childlike. It showed the basic shape of the building and rough positions for major assemblies. Sorensen's calculations were carried entirely in his head, but when he met Edsel Ford for breakfast and spread that creased hotel stationery across the table, Ford understood immediately what he was looking at. It was a factory designed backwards. Most plants evolved from the product they built. This one would force the product to evolve to fit the factory. At lunch, Sorensen told Major Reuben Fleet, Consolidated's president, that Ford would build complete, aircraft or nothing. Fleet was offended. Consolidated had been building aircraft since 1923. Ford built cars. The fleet offered a counter-proposal. Ford could manufacture 1,000 wing sections, under contract, under supervision. Sorensen's response was blunt: complete airplanes or no deal. The government, desperate for production capacity, sided with Ford. On April 18, 1941, 5 weeks after receiving a $3.4 million initial contract, Ford broke ground on what would become the largest manufacturing facility under one roof anywhere in the world. But breaking ground was the easy part. The fields that became Willow Run had been a summer camp for boys whose fathers died or were disabled in the First World War. Henry Ford, who maintained complicated feelings about both war and charity, believed in teaching children self-reliance through agricultural labor. They lived in tents, attended dawn church services, and spent 12-hour days farming. It was harsh, but it was purposeful. In the summer of 1941, as bulldozers leveled those fields, a different kind of purpose took shape. Albert Kahn, the industrial architect who had designed Ford's Highland Park plant and dozens of others, translated Sorensen's rough sketch into engineering reality: 3.5 million square feet of factory space. An L-shape to avoid crossing county lines. 2 massive turntables to rotate fuselage sections 90 degrees near the end of the line because the building had to turn. The main structure rose in sections. Workers sealed off completed portions with plywood partitions and began installing equipment before construction was finished elsewhere. 5 major contractors worked simultaneously. The adjacent airport, with 6 runways and 3 hangars, poured its final concrete load on December 4, 1941. 3 days before Pearl Harbor brought America formally into the war everyone knew was coming. But a building is not a factory. A factory requires tools, and this is where the scale of Sorensen's ambition became clear. Consolidated had no proper blueprints. They had sketches, templates, and some rough specifications. Ford engineers needed complete technical drawings for every component of the B-24, so they did something extraordinary. They took delivery of 2 complete Liberators, flew them to Dearborn, and disassembled them piece by piece. 1,000 engineers, working 7 days a week in round-the-clock shifts, measured every dimension of every part. They generated 5 million square feet of blueprints. It took nearly a year. While that was happening, another team designed the custom tooling Willow Run would need. 1,600 machine tools, some standing 60 feet tall. 11,000 fixtures and jigs, each one precisely machined to hold specific components at exact positions. 30,000 metal stamping dies, equivalent to designing 8 or 9 complete automobile model changeovers. And here was where the fundamental conflict emerged. the one that would define Willow Run's early struggles. Consolidated aircraft built using craftsman principles: measure, cut, fit, adjust. Each part was slightly unique. Skilled mechanics compensated for variations. It was slow, but it worked, and it produced reliable aircraft. Ford needed every part to be identical. Mass production demanded interchangeability. A rivet hole drilled in wing panel 3000 must align perfectly with the corresponding hole in fuselage section 3000. No adjustment, no fitting. No craftsman looking at the work and deciding where to compensate. The tool designers understood this. They designed permanent jigs to hold wing sections in exact positions. Robert Clem and his team calculated that Consolidated's temporary jig method, building a new fixture for each wing and requiring 250 man-hours of assembly time, was impossible to scale. They proposed permanent fixtures that could be loaded and unloaded by overhead cranes. Wings would slide in, be clamped into position automatically, and workers would drill holes in locations determined by the fixture itself. In theory, this would reduce wing assembly time from 250 hours to 1 hour, maybe less. But there was a problem, and it was significant enough that some engineers argued the entire concept was flawed. Building those permanent jigs required solving a three-dimensional geometry problem of extraordinary complexity. The B-24's wing wasn't flat. It had compound curves, dihedral angle, taper. Every cross-section was different. Creating a fixture that could hold that shape with 2/10,000ths of an inch tolerance, while still allowing the wing to be loaded and unloaded by crane, required machining precision that pushed the absolute limits of 1941 metalworking capability. And it had to work perfectly the first time, because there was no time to build a second version. Some engineers advocated for Consolidated's method: build temporary jigs for each wing. Yes, it was slower. Yes, it required more skilled labor. But it was proven. It worked. Aviation had always been a craft industry. Why force it to be something else? The debate was settled by mathematics and desperation. In May 1942, 1 year after construction began, Willow Run had produced exactly one B-24, one aircraft. The plant was nicknamed Will It Run in newspapers across the country. Senator Harry Truman launched an investigation, his committee arriving in Detroit with what one observer called blood in their eyes. The tooling team didn't have time to debate whether their permanent jig system would work. They had to make it work, and so they did something that became characteristic of Willow Run's eventual success. They stopped arguing and started building. The center wing jig that Robert Clem's team completed in late May 1942 was a marvel of mechanical engineering. It weighed several tons. Steel framework precisely machined to match the B-24's wing curvature. Spring-loaded clamps that automatically positioned incoming wing sections. Alignment pins that guided drill bits to exact locations. The whole assembly could be loaded by overhead crane in under 4 minutes. The first test wing went into the jig on June 2nd. 23 workers, most with less than 2 months of factory experience, drilled 367 rivet holes in 90 minutes. Every hole aligned within tolerance. No craftsman needed to measure anything. The jig itself guaranteed correctness. The second wing took 72 minutes. The third, 61. By the end of June, wing assembly time had dropped to 53 minutes per section. This was the breakthrough, though few people outside the engineering team understood its significance at the time. The permanent jig didn't just save time, it fundamentally changed what kind of worker could build a bomber. Consolidated's methods required craftsmen, people with years of experience, who understood how aircraft went together, who could see when something was wrong and correct it. America didn't have enough of those people. The military had drafted most of them. Ford's method required only the ability to follow instructions, position the part, activate the clamp, drill where the template indicates, remove the part. The jig eliminated judgment from the process. It replaced skill with precision tooling. But this innovation, as successful as it proved, was only one piece of a vastly larger puzzle. By summer of 1942, Willow Run faced a crisis that had nothing to do with engineering. The plant couldn't keep workers. In a single month, Ford hired 2,900 people and lost 3,100. The plant was 45 minutes from Detroit by car. Wartime gasoline rationing made that commute increasingly difficult. There was no local housing. Workers slept in shifts, sharing beds with people who worked opposite schedules. Some slept in cars in the parking lot. The nearest restaurants couldn't handle the volume. Supply shortages meant that cafeterias inside the plant sometimes ran out of food by mid-shift. The federal government eventually built an entire community adjacent to the factory. Dormitories for single workers, small houses for families, roads, sewage systems, schools. It was one of the largest emergency housing projects undertaken during the war. Even then, the turnover remained brutal. 8,200 workers per week were drafted into military service. Training was continuous. The Aircraft Apprentice School ran classes for up to 8,000 students per week, teaching basic factory skills in crash courses that lasted days, not months. Who were these workers? Farmers from Kentucky and Tennessee, housewives from Detroit suburbs, secretaries, clerks, elderly men beyond draft age, teenagers too young to enlist, women who had never worked outside their homes, African Americans who had been barred from automotive industry jobs by discriminatory hiring practices but were now needed desperately enough that even Henry Ford's prejudices had to bend. By May 1942, 15% of Willow Run's workforce was female. Within a year, that number reached 35%. More than 15,000 women worked the assembly line at peak production. They were paid 85 cents per hour, the same as men doing identical work, a rarity that reflected wartime necessity more than enlightened labor policy. And there were others. Ford recruiters quietly hired 8 men of short stature, some from entertainment and circus backgrounds. Their job was essential and dangerous. The B-24's wings contained fuel tanks. Those tanks needed to be sealed and inspected from the inside. The access spaces were too narrow for average-sized workers. These men crawled into wing interiors to hold backing plates while riveters worked from outside, to seal fuel cell seams, to inspect welds in spaces where a normal-sized person couldn't fit. One of them, Henry Badeau, was photographed working inside a wing section in 1943. He's crouched in a space perhaps 18 inches tall, holding a pneumatic tool, surrounded by aluminum ribs. The image is striking because it shows what mass production actually meant, not replacing workers with machines, but finding ways for every human being, regardless of size or background, to contribute their labor toward a single overwhelming purpose. They were building, on average, over 300,000 rivets into each aircraft, more than 500 different sizes. Every rivet hole had to align, every rivet had to seat properly. A single mistake could cause structural failure in combat. The pressure was immense and unrelenting. Thank you for reading Part 1. Please let me know when you're ready for Part 2 of the complete script, which will continue from here covering the breakthrough period and ultimate success of Willow Run's innovation. The breakthrough came not from a single innovation but from hundreds of small ones, each solving a specific problem that scaled across the entire production line. Consider the engine installation process. At Consolidated San Diego facility, hanging a Pratt & Whitney 1800 horsepower radial engine onto a B-24's wing required 4 hours per engine, 4 engines per aircraft, 16 hours total. The process involved positioning the engine on a makeshift steel fixture mounted to a truck bed, using surveyor's transits to align the propeller shaft centerline, then slowly guiding the engine into place while mechanics made minute adjustments. Ford's engineers designed a hydraulic lift platform with precision alignment guides built into the structure itself. The platform positioned the engine at the exact height and angle needed. Pneumatic clamps held it, steady. Workers bolted it into place following a numbered sequence painted directly onto the engine mounting frame. Time per engine dropped to 37 minutes. That innovation alone saved approximately 14 hours per aircraft. Multiply that across thousands of bombers, and those saved hours became weeks, then months of production capacity that simply hadn't existed before. Or consider the fuselage assembly. The B-24's body was built in sections that had to mate together with perfect alignment. Consolidated accomplished this through careful measurement and skilled fitting. Ford created an overhead bridge conveyor system, designed by Albert Kahn, that lowered fuselage sections onto the assembly line exactly as automobile bodies were dropped onto chassis at Highland Park and River Rouge plants. The sections were pre-positioned by the conveyor itself. Workers bolted them together following templates that showed exactly where each fastener belonged. The paint system was another revolution hidden in plain sight. Consolidated painted completed aircraft outdoors, by hand, with brushes and spray guns. It took 3 days per bomber. Ford installed an automated paint line that pulled aircraft through a series of spray booths using a powered conveyor, 47 minutes from bare aluminum to completed livery. Each innovation required custom tooling, fixtures that didn't exist anywhere else in the world, because no one had ever attempted to mass-produce aircraft on this scale. The tool design group worked around the clock, 7 days a week, for most of 1942. When they encountered a problem they couldn't solve with existing metalworking techniques, they invented new ones. Robert Clem's team designed a multifunction machining center for the center wing assembly that completed 42 separate precision operations simultaneously. The wing section was positioned on a rotating platform. Drill heads descended from above and below. 17 minutes after loading, every required hole was drilled, every mounting surface was milled, every inspection point was gauged, all within tolerances measured in 10,000ths of an inch. This was unprecedented. Individual machine tools were common. Multifunction centers that could perform dozens of operations on a massive aerospace component didn't exist. Clem's team built one anyway because the production schedule demanded it. But tooling innovations meant nothing without solving the constant design changes that plagued early production. The relationship between Willow Run and Consolidated Aircraft was, to put it charitably, strained. Consolidated still held portions of the original B-24 contract. They continued to refine the design, making improvements based on combat feedback from Europe and the Pacific. Longer-range fuel tanks, modified tail gun positions, strengthened landing gear, better bomb release mechanisms. Each change was militarily justified, each change was operationally necessary, and each change required Ford to halt production, retool fixtures, generate new blueprints, retrain workers, and restart the line. In a single 6-month period, spanning late 1941 through early 1942, Consolidated issued over 2,000 engineering change orders. Many were minor, some were trivial, but each one had to be evaluated, incorporated, and verified. The tool designers in Dearborn would complete a set of dies for stamping a particular fuselage panel, only to receive word that the panel dimensions had changed. The $10,000 and 6 weeks invested in that die were now worthless. Start over. This was the crisis that brought Senator Truman's committee to Michigan in February 1943. The investigation was withering. Congressional staffers documented cost overruns, production delays, and quality problems. They noted that Willow Run had been designed as an automotive assembly line, despite the warnings of experienced aircraft manufacturers. They pointed out that Consolidated, Douglas, and other established producers were meeting their quotas while Ford struggled. The Truman Committee's initial assessment was damning. Some investigators privately recommended cancelling the Willow Run program entirely. But then something changed. The committee members toured the facility. They saw the scale of what Ford had built. They watched farmhands and housewives assembling components with precision that matched or exceeded handcrafted aircraft. They saw the inventory of tooling, the training programs, the housing projects. They began to understand that Willow Run wasn't struggling because Ford didn't know how to build things. It was struggling because no one in human history had ever attempted to build aircraft this way. The committee's final report, issued in May 1943, concluded, Willow Run compares favorably with any other airplane plant in the country as far as actual production work is concerned, and we have seen them all. More importantly, the investigation prompted a crucial administrative change. Until mid-1943, authority for the B-24 program was split between Ford and Consolidated. Design changes flowed through multiple approval layers. Decision-making was slow and often contradictory. In June 1943, the government consolidated program management under a single authority. Design changes had to be batched and scheduled. Non-critical modifications would be implemented at planned intervals, not continuously. Critical safety improvements would still happen immediately, but they required explicit justification. This administrative reorganization, more than any single technical innovation, allowed Willow Run's tooling strategy to finally prove itself. With a stable design, the permanent jigs and fixtures could run for weeks at a time without modification. Workers developed rhythm and expertise. Training stabilized because procedures weren't changing daily. Quality improved because the process was repeatable. Production numbers told the story. October 1942, 1 aircraft completed. December 1942, 56 aircraft. June 1943, 140 aircraft. December 1943, 365 aircraft. By January 1944, Willow Run was producing one B-24 Liberator every 63 minutes. What did 63 minutes actually mean? It meant that every 63 minutes, on average, a complete aircraft rolled out of the final bay. But this was an average across continuous 24-hour production, not a literal assembly time for one airplane. The assembly line itself stretched over a mile. An individual aircraft spent approximately 33 hours on the line from initial fuselage assembly to final inspection. But because the line was continuous, with aircraft at every station simultaneously, the output rate was determined by the slowest bottleneck. Once every bottleneck was optimized to complete its work in under 63 minutes, the entire system achieved that production rate. The plant ran 2 9-hour shifts per day, 6 days per week. The remaining 4 hours each day were used for restocking parts, changing worn tooling, and performing maintenance. This rhythm allowed sustained production without accumulated fatigue or equipment failures. At peak employment in mid-1943, 42,000 people worked at Willow Run. By summer 1944, when production hit its maximum rate, employment had dropped to 17,000. The reduction reflected efficiency improvements. Better tooling meant fewer workers needed per aircraft. Better training meant less waste and rework. The cost per aircraft fell from $379,000 in early 1943 to $216,000 by mid-1944, a 43% reduction. Adjusted for inflation, that's approximately $6.1 million to $3.5 million in today's currency. The savings came almost entirely from reduced labor hours per aircraft, which dropped from over 30,000 hours to under 18,000 hours over the same period. Those numbers represented more than efficiency. They represented American industrial capacity operating at a level that no other nation could match. Germany's entire aircraft industry produced approximately 39,000 aircraft in 1944. Willow Run alone produced over 4,000 B-24 seconds that year. Add in Consolidated's Fort Worth plant, Douglas's Tulsa facility, and North American's Dallas operation, and total B-24 production exceeded 9,500 aircraft in 1944. More heavy bombers than Germany's entire aviation sector produced of all aircraft types combined. This was the strategic significance of what happened inside that Michigan factory. The innovations in tooling and process engineering didn't just make production faster, they made American industrial output overwhelming. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The B-24 seconds that left Willow Run flew to every theater of the war. They bombed oil refineries in Ploiești, Romania, in one of the war's most costly air raids. They provided anti-submarine coverage in the Atlantic, hunting German U-boats that threatened supply convoys. They struck Japanese positions across the Pacific, flew the hump over the Himalayas to supply Chinese forces, and participated in the strategic bombing campaign that destroyed Germany's industrial capacity. The aircraft themselves were not universally loved by their crews. The B-24 was harder to fly than the B-17 Flying Fortress, less forgiving of pilot error, more susceptible to damage. Crews called it the flying coffin because hits to the wing-mounted fuel tanks could turn the aircraft into a fireball, but the Liberator had advantages that mattered strategically: longer range than the B-17, greater bomb load, better fuel efficiency. These characteristics made it essential for missions where distance mattered more than defensive capability. The Pacific Theater relied heavily on B-24 seconds for exactly this reason. Island-hopping campaigns required aircraft that could reach targets over vast ocean distances, strike, and return. By war's end, Willow Run had produced 8,645 B-24 seconds, nearly half of all Liberators built during the war. Combined with other production facilities, over 18,000 B-24 seconds were manufactured, making it the most produced American military aircraft in history. More than any fighter, more than any other bomber, more than any transport or trainer. The scale was staggering, but what matters for understanding Willow Run's significance is not the raw numbers. It's what those numbers represented about American manufacturing capability. Consider the mathematics of the center wing jig, the innovation that started this entire story. At Consolidated's rate of 250 man-hours per wing section, producing wings for 9,000 aircraft would require 2,250,000 man-hours of labor. At 8 hours per day, that's 280,000 working days, or roughly 766 years of continuous single-worker effort. At Ford's rate of 1 hour per wing section, the same work required 9,000 man-hours, 1,125 working days, 3.1 year. The difference, 2,241,000 man-hours, was the direct result of replacing craftsman methods with precision tooling. Those saved hours weren't merely efficient. They were at capacity that could be directed elsewhere, toward building more aircraft, training more crews, supporting more missions. This was true across every innovation implemented at Willow Run. The engine installation platform, the automated paint system, the multi-function machining center, each one traded initial tooling investment for permanent labor reduction, and because the tooling could be replicated, the gains scaled. Robert Clem's team didn't just design a jig for Willow Run, they designed a jig that could be manufactured and installed at other facilities. Consolidated's Fort Worth plant adopted modified versions of Ford's tooling systems, so did Douglas in Tulsa. The innovations spread because they worked, and because the war demanded that every advantage be exploited fully. But there was a cost to this transformation, one that became apparent only after the war ended. On June 28, 1945, the last B-24 rolled off the Willow Run assembly line. The war in Europe had ended in May. Japan would surrender in August. The contracts were cancelled. Production halted. 42,000 people had worked at Willow Run at peak employment. Within weeks, that number dropped to 7,400. By the end of 1945, fewer than 2,000 remained, primarily security and maintenance staff. The factory, the largest manufacturing facility in the world, sat mostly empty. Ford had an option to purchase Willow Run from the government after the war. The company declined. The peacetime market for heavy bombers was precisely zero. Converting the facility to automobile production would require demolishing most of the specialized tooling and reconfiguring the building entirely. It wasn't economically viable. Kaiser Frazer Corporation purchased Willow Run in 1946 for $15 million through the War Assets Administration. They produced automobiles there until 1953. General Motors bought the facility after a fire destroyed their Livonia transmission plant, using Willow Run to manufacture transmissions until 2010, when GM's bankruptcy, forced closure, and eventual demolition. Of the original 3.5 million square feet, Only 175,000 square feet remain, preserved as part of the Yankee Air Museum. The rest were demolished in 2013 and 2014. The site is now the American Center for Mobility, a testing ground for autonomous vehicles. The workers dispersed. Some returned to farming. Some found jobs in Detroit's automotive plants. Many of the women who had riveted B-24 seconds together were expected to return to domestic roles, though not all did. The war had demonstrated what women could accomplish in industrial settings, a lesson that would resurface decades later. The tool designers moved on to other projects. Robert Clem returned to Ford's automotive division, applying aerospace precision techniques to car manufacturing. Charles Sorensen retired in 1946, his 40-year career culminating in the most ambitious production program in manufacturing history. No parades celebrated the tool designers. No monuments honored the machinists who built the jigs and fixtures. Their work was classified during the war and largely forgotten after it. The public remembered Rosie the Riveter. They remembered the B-24 seconds themselves, the missions they flew, the crews who didn't return. They didn't remember the permanent wing jig that made it all possible. This is typical of how history remembers innovation. The drama is preserved. The technique is forgotten. We remember that America built nearly 20,000 heavy bombers. We forget that doing so requires solving thousands of individual engineering problems, each one small, each one essential. There is an irony embedded in Willow Run's story that becomes clear only with distance. The factory represented the absolute apex of centralized, coordinated, top-down manufacturing planning. Every process was specified. Every motion was timed. Workers were components in a vast mechanical system designed to transform raw materials into aircraft with maximum efficiency. It was Fordism applied to aerial warfare, and it worked brilliantly. But that system only functioned because of thousands of individual innovations from people who weren't senior executives or famous engineers. The machinists who modified standard drill presses to handle aircraft aluminum, the line supervisors who reorganized workstations to eliminate wasted motion, the workers who suggested better ways to position parts or sequence operations. The permanent wing jig wasn't designed by Charles Sorensen. He created the overall plant concept. Robert Clem's team designed the jig, but they designed it based on input from workers who actually assembled wings, who understood where the bottlenecks occurred, where measurements were most critical, where tolerances could be relaxed slightly without compromising structural integrity. This pattern repeated across every innovation at Willow Run. Top-down planning created the framework. Bottom-up knowledge filled in the details. The system worked because both elements were present. After the war, American manufacturing gradually forgot this lesson. Mass production became associated purely with management-driven efficiency, with time-motion studies and standardized procedures. The knowledge held by workers, the small innovations that emerged from daily problem-solving, was devalued. When Japanese manufacturers began outcompeting American companies in the 1970s and 80s, they did so partly by rediscovering what Willow Run had demonstrated, that the people closest to the work often understood it best. Toyota's production system, which revolutionized global manufacturing, incorporated Kaizen continuous improvement driven by workers themselves. It emphasized flexibility, quality, and waste reduction. These principles weren't invented by Toyota. They were rediscovered. Willow Run had demonstrated all of them 30 years earlier. The difference was that Willow Run's innovations were driven by wartime necessity and then abandoned when that necessity ended. Japan's manufacturers, rebuilding from devastation, learned those lessons and institutionalized them. They made continuous improvement a permanent feature of industrial culture rather than a temporary wartime expedient. This is perhaps the deepest irony. The most advanced manufacturing facility in the world in 1944 taught lessons that America forgot and had to relearn from others decades later. But there is something else worth considering about Willow Run, something that speaks to why this story matters beyond historical interest. The central wing jig solved a problem that seemed insurmountable: how to achieve precision without expertise. It did so by embedding expertise into the tool itself. The jig was, in a sense, crystallized knowledge. Decades of aircraft manufacturing experience, translated into steel and aluminum, made available to someone who had never built an airplane before. This principle, embedding expertise into tools, is the foundation of all technological progress. A computer programmer doesn't need to understand how transistors work. The programming language embeds that knowledge. A surgeon using a Da Vinci robot doesn't need to understand the control algorithms. The robot embeds that knowledge. We advance by building tools that make previously difficult things possible for more people. But there's a tension embedded in this process. When expertise is embedded in tools, what happens to the people who hold that expertise? The craftsmen at Consolidated who could hand-fit wing sections lost their competitive advantage when jigs eliminated the need for hand-fitting. Their skills became less valuable. Eventually, it became obsolete. This wasn't unique to Willow Run. It's the story of industrialization generally. Weavers displaced by powered looms. Blacksmiths displaced by factory metalworking. Telephone operators displaced by automated switching. Each wave of automation creates abundance and obsoletes expertise simultaneously. Willow Run did this to aircraft manufacturing, but with unusual speed and visibility. In 18 months, the plant transformed bomber production from craft to industry. The craftsmen who built B-24 seconds in San Diego in 1941 would have been mystified by the process at Willow Run in 1943. They would have watched farmhands doing work that previously required years of training, and the cognitive dissonance would have been profound. Were those craftsmen wrong to feel displaced? No. Their skills genuinely had been made obsolete. Were the farmhands who replaced them less worthy? Also no. They were doing different work, enabled by different tools. This is the uncomfortable reality embedded in stories of industrial innovation. Progress creates winners and losers. The tool designers who made Willow Run possible enabled bomber production that helped end the war. They also eliminated jobs for thousands of aircraft craftsmen whose skills were no longer needed. We tend to remember the progress and forget the displacement, but both are real, both matter. On a shelf in the Yankee Air Museum, there's a small aluminum fragment. It's a section of wing skin from a B-24 that was scrapped after the war. Someone drilled rivet holes along one edge. The holes are perfectly aligned, perfectly spaced, perfectly sized. You can run your finger along them and feel the precision. Those holes were almost certainly drilled using a fixture designed by Robert Clem's team. The person who drilled them might have been a farm boy from Tennessee or a housewife from Detroit. They probably don't remember this specific aircraft. They drilled thousands of holes in hundreds of wings over months or years of work. But those holes are perfect. And because they're perfect, the wings held together in flight. Some crew flew missions in that aircraft. Maybe they survived the war because the wing didn't fail. Maybe they died in some other way. Either way, those rivet holes did their job. This is what remains when we strip away the drama and mythology. Perfectly aligned holes in aluminum. Embedded expertise. Crystallized knowledge. The physical residue of solving a problem that once seemed impossible. The war was won by many things: superior resources, better intelligence, braver soldiers, wiser strategy. But it was also won by people who figured out how to drill perfect rivet holes, consistently, repeatedly, at scale, using workers with minimal training. That sounds prosaic, perhaps anticlimactic, but it's true. And the tools they designed to make it possible changed manufacturing forever, even if most people have forgotten they existed. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.